Alright, everyone, we talked about the transport of oxygen on blood cells, but today I want to talk about the transport of carbon dioxide because it's important to get the carbon dioxide from the tissues and take it back to the lungs, right, for that gas exchange. Alright, now, 7% travels dissolved in the blood, 20% bound to hemoglobin, and I want to talk about that for a second. When the carbon dioxide binds to the hemoglobin, it helps the oxygen dissociate. If you kind of remember how we talked about the other day, how the more carbon dioxide there is, the more the hemoglobin it lets go of the oxygen. It dissociates, which is great because that means your tissues need more oxygen. All right, and 7%, 20%, so 70% travels dissolved as bicarbonate. What's bicarbonate? Remember that bicarbonate buffer equation back from Bio 141? So we have carbon dioxide and what is plasma? Mostly water, right? Carbon dioxide and water brings us to carbonic acid, H2CO3. Notice how we don't lose any atoms, right? We keep everything. And then that dissociates in water. You get a hydrogen ion and bicarbonate. So what do we do with this now? And I want you to notice where this is taking place. Where is this happening? In a red blood cell, right? See the red outline. It's supposed to be a red blood cell. So this is taking place in a red blood cell. And it happens naturally, but not quite at the speed we need it to. So we have an enzyme, carbonic anhydrase. And this will catalyze the reaction. In fact, you know what? It will catalyze the reaction this way or this way. Very convenient. Carbonic anhydrase. And look, carbonic acid is here in the middle. Alright, so carbon dioxide, water, carbonic acid, hydrogen ion, and bicarbonate. I would write this out a few times until you fully understood. And I also have something online, the bicarbonate buffer equation explanation. Read that if you're having any trouble with it, and let me know because you will absolutely see this again. Again and then again after that. So we have this is happening in a red blood cell. Once we get over here to bicarbonate, the bicarbonate leaves the red blood cell. It goes out into the plasma. So it is going to leave. All right. The hydrogen ion is going to bind to hemoglobin. Now we have this negative charge going out into the plasma. What if we had, do we really want that much negative charge going into the plasma? How could we counteract this? And I have if you see the green here, that's supposed to be a clue. So that's a negative charge. What if we took something negative that was in the plasma and pulled it into the red blood cell? We can actually do that. How about chloride? So we have chloride in our plasma, and when the bicarbonate comes out into the plasma, it has a negative charge, but the negatively charged chloride goes in. Now look at this, the chloride can come back out. Because what about when we get to the lungs? We need to transform that back to carbon dioxide, right? So we have carbonic anhydrase going this direction. But at that point, when we're in the lungs, the bicarbonate is going to go back in. So we put lungs. When the bicarbonate goes back in, chloride comes back out. So the chloride is kind of shifting in, shifting out to balance the charge from the bicarbonate. Does that make sense? So carbon dioxide is going in, carbonic anhydrase, this equation, to bicarbonate. Bicarbonate comes out. When that happens, chloride goes in so that our charge is equal. When we get to the lungs, bicarbonate goes back in to go back this direction to carbon dioxide, and chloride comes out to balance the charge again. And we have a term for this. The chloride shift. And you're definitely going to see that on an exam. At least on a multiple choice question. So, carbonic acid, bicarbonate, chloride shift, carbonic anhydrase, all terms you would want to use if you were writing an essay on this. And so this is about 70% of, let me write that in here, 70% dissolved as bicarbonate. And where is this happening? Red blood cell, right? But some of it is going in and out between the red blood cell and the plasma. Does that make sense? Bicarbonate buffer equation. You really want to have that memorized. I haven't figured out how to have you write an equation yet on an online exam, but I bet the course director has figured it out. So I would write it out and make sure you understand it and email me. Ask me questions if you don't understand that. All right, thank you. Goodbye.